So hey guys, in this video we are going to solve the problem based on what the three-phase full converter drive, which is to basically we are using for the speed control of the motor, which motor separately excited DC motor by using the three-phase full converter drive. Okay, so you have to remember the formulas for three-phase full converter. There are only two formulas, VA and VF, and separately excited DC motor we have solved many problems. So that formulas also entire thing you have to remember. Now speed of the motor rating is given over here 20 HP, 300 volts and 1800 RPM it is given. Okay, that is the rated values of the motor. Next, what you have to, the main concern here is that the field current is also controlled by the three-phase pole motor, that is set by this thing, the AC input voltage. So from here the main part starts. The AC input is a three-phase because this is a three-phase pole converter, that is the star connected. So star connected, not delta. So star connected 208 208 volts 60 hertz supply. So from here we can write the data given. So basically it is given V line voltage VL is equal to 208. Okay, so you have to understand here that the AC input voltage Y connected is 208. The AC input voltage is a three phase. The line voltage is given. So we have to convert it to, we will be using phase voltage VP. How to find the phase voltage? So each phase the voltage will be VL by root 3. This is for the star connection. If it is delta connection, it is directly V phase. Okay. So VL is equal to V phase directly, but it is the star connection. That's why V phase is equal to VL by root 3. So 208 by root 3 is 120 volts. So whatever is the given data, that will be considered as what? The line voltage. Next, the armature resistance Ra is given and the field resistance RF is also given. So you have to note these 2 points, and the water voltage constant is also given. So that all things you have to write. So Ra is given as 0.25 ohm. RF is also given, which is 0.245 ohm. Then motor voltage constant is given as 1.2 volt per ampere. Radian per second is the unit. Then the armature and the field current are, can we assume sense? Okay, that and all is fine. Determine the first part of the question, the delay angle of the armature converter. See, they'll be having two delay angles. One is for the armature circuit, other is for the field converter. Field converter alpha F will be there, armature converter alpha A. So we have to find out alpha A, which is nothing but the armature converter delay angle. If the motor supplies the rated power at the rated speed, that is fine. So first part of the question will start by finding alpha A. We are asked to find out alpha A. So what formula will be applied? We know the formula of the three-phase full converter for VA. VA will be related to alpha A. VF will be related to alpha F. So VA formula is nothing but 3 root 3 Vm by pi cos alpha A. This is the formula for VA. VM. So where is VM sitting? VM is basically whatever you have considered here, V phase, that is treated as VS. So VM will be root 2 times of VS. That means V phase here. So it will be 120 into root 2. 120 into root 2 is 120 into root 2. Okay, into root 2 it will be 169.7 volts. That also you have to mention. So that means in the question it is given line voltage. We have to consider whatever the voltage is given as line voltage. We have to then consider the phase voltage. Then phase into root 2 will give you the maximum peak voltage that you have to consider over here. Okay. Okay, that is fine. Now what about alpha A? In order to find out alpha A, all other things should be known. That means I need to know Vm. Pi is anyways constant, this is constant, but Va I don't know. Correct? Va value I don't know in order to find out alpha. So I need to find Va using the what formulas which we have studied for separately excited motor. So Va is equal to IARA plus Eg. This is the formula for separately excited DC motor armature voltage, right? Now in this, whether I know IA value is not given. IA value is not given. RE value is given, EG value is also not given. So two things are not given, IA is also not given. So let us first find out IA. Always remember, in order to calculate IA, what you are going to do, that we have been given some rated values. That is nothing but 20 HP, 300 volts and all is given. Using these rated values, I am going to find out I rated. So remember, the P value, the power is equal to V into I. V rated into I rated. Okay. So here V rated means the rated value given in the question. What is P? P is nothing but 20 HP. 20 HP means in watts we can convert. So P is equal to 20 HP, which you can write it as into 746. That means uh, mother. So power, in order to find out, just you take the HP value 20 HP into 746, you multiply, because 1 HP is how much watt? 746 watts. So 20 HP will be 20 into 746, right? That will be some watts. That you are going to divide it by, see, I need to find out I rated. So I rated is equal to P by V rated, right? So what is P? That's what we are writing here. So 20 into 746 divided by, it is in watts, divided by V rated. V rated is given in the question, that is 300 volts, not 208. Okay, V rated values of the motor we are taking. So rated value of the motor is 300 volts. That when you multiply and divide, you will be getting the answer as 49.73 ampere. Now this is I rated. What about IA? See, remember, it is IA is same as what I rated. So that is equal to 49.73 amperes. So IA part is done. So you got IA. Now we have to find out what? EG. In order to find out EG, what is the formula we are having? kV into omega into IA. IF. kV into omega into IF we are having. No, kV is given in the question, which is a motor voltage constant. It is given in the question. Okay, kV is given. That is fine. Now whether omega and IF is given, IF is not given. Remember, IF is not given. Omega, whether it is given. See, they have said that what is the speed given over here? 1800 RPM. That is the speed given over here. So we are going to utilize that. VF we don't know. Omega is given 1800 rpm, but omega always should, in this formula, should be radian per second. In radian per second only you can substitute. So if I will find out first. So if is equal to vf by r. Now what about the field voltage vf? In order to find out vf, we again have to go for the three phase full converter formula. As I said, vf is equal to 3 root 3 Vm by pi into cos alpha f. The same formula. See, here we are having for the armature voltage. Here we are going for the field voltage. Alpha f, whether it is given? No, always remember, whenever you are calculating Vf, we are going to consider the alpha f value as what? 0. The delay angle for alpha is always 0 degrees in order to obtain the maximum voltage and current. Whenever you are calculating, remember that. Alpha f is 0 means cos 0 is what? 1. So this entire thing becomes 1. So Vf becomes what? 3 root 3 Vm. Vm value, as we have calculated, it is 169.7 divided by, here we can see the same thing. Vm we calculated 169.7 divided by pi into cos, oh, that is done. Okay, so what is the answer? Vf we are getting 280.7 volts we are getting. Okay, so Vf is done. Now I have to find out If. So it will become If is equal to Vf by Rf. So it is Vf is 280.7. Rf is given in the question. The field resistance is 245 ohm. So you will be getting the answer as 1.145 amperes. Okay. negative 1.146 amperes. IF is done. After getting IF, I'll substitute in this formula, but before that, omega you convert. So omega given in the question is in 1800 rpm. I need to convert it into radian per second. How will you convert? Remember the simple thing, rpm to radian per second, you have to just multiply the rpm by what? Pi by 30. If you want to convert radian per second to rpm, you have to just multiply radian per second with reciprocal of that 30 by pi. Okay. So here I am going to multiply 1800 with pi by 30 in order to convert it into what? Radian per second. So which is equal to 188.5 radian per second. Done. So after that you can substitute in this EG formula. So this will be quite confusing. We are still in the A part itself. You have to understand this concept that we are still doing the A part. So EG becomes kV omega into IF. kV motor constant, voltage constant is given. How much? 1.2. 1.2 into omega, just now we calculated 188.5 into IF value is how much? 1.146. We got it just now. So you'll substitute, we'll be getting EG value as 259.2 volts. Back EMF we got. After getting back EMF, I am going to substitute where? In this formula to get to VA. I'll explain once again the description part, the briefly. For short form, I'll explain you. Like A part will be quite confusing because it is taking a long time to calculate itself. Okay. So VA is equal to, as we know, it is IARA plus EG. So IA we found out, which is same as I rated using the power formula. So we are getting I rated the same as 49.73. 49.73 into RA, armature resistance, as we know it is given in the question, 0.25, plus EG just now we calculated 259.2. So you'll be getting VA, armature voltage, as 271.63 volts. After getting VA, I am going to substitute in this formula of VA so that I can get alpha A. So as we know, VA is equal to 3 root 3 by pi Vm into cos alpha A. I need alpha cos, that means alpha A. So shift everything that side. Cos alpha A is equal to Va into pi divided by 3 root 3, correct, into Vm. That is the thing. Now if I remove cos, okay, that will do afterwards. So what is the Va value? Just now we got 271.63 into pi divided by 3 root 3 into Vm. What is Vm now? Vm we just calculated whatever the V phase is there, that we multiplied with root 2 and got 169.7. 169.7. So you will be getting the alpha A, not alpha A, this particular value. What is it? No need. So whatever this value is there, that you have to take what? Cos inverse of this entire thing. That means this entire thing. So you will be getting the final answer as what? 14.59 degrees. So whatever the alpha you will be getting, it is in degrees, not in radius. Okay. No need to change anything. Directly you'll be getting in degree itself. So alpha A delay angle, we got the armature. So I'll shortly explain you what I have done. So this A part, it's quite lengthy. You can see it took this much amount of time to explain. So I'll give you short description of what I have done. Just a small description. See, if you want to calculate alpha A, you have to go for the formula of VA. That is 3 root 3 by pi Vm cos alpha A. If you want, you can skip this part. Okay, I'm just explaining short briefly because alpha is sitting here, so that you can use the formula. In order to calculate alpha A, I'll just take the cos inverse of Va pi divided by 3 root 3 Vm. Simple. In this, Va we don't know. Vm we calculated by using given question, it is VL 208. We divided it by root 3 in order to get V phase. Then V phase we took answer and multiplied with root 2 in order to get VA. This is the procedure to calculate VA. Simple. Done. In order to calculate VA, what we are doing? VA formula, separately excited DC motor. I hope you remember. It is IARA plus EG. Here only thing is given is RA. These two things are not given. So I need to find out then EG. EG is equal to kV omega IF. Okay. As well as I need to calculate IA also. IA can be calculated by using the power formula. It is same as I rated. How to find out I rated? It is by power is equal to P is equal to VI, volt into ampere. So from this I is equal to power by the voltage rated. So it is given in the question. Voltage you have to convert into watts because 20 HP it is given. So you have to convert it to watts into 746 divided by voltage rated is 300. Not don't take 208 and come. Okay. EG. How to calculate EG? kV motor constant it is given. Omega it is 1800 rpm. You have to convert into radian per second. You have to just multiply by pi by 30. IF is nothing but again you have to go for formula VF by RF. So VF again you have to go for the same formula. This formula itself, that is 3 root 3 Vm by pi into cos alpha f. This alpha f you have to consider 0, so this entire thing becomes Vm. Anyways, you know, you calculate Vf, Rf is given, then you can calculate Eg, substitute back in this Va formula, get to Va, then Va you have to substitute back in this formula to get what? Alpha. This is the entire procedure. I hope you understood this procedure. B part. First part was quite lengthy. Let us go for the second part. No load speed if the delay angles are same in first part itself. That means the delay angle we have to consider as 60 degree only, whatever it is given here, right? Oh, sorry. The delay angle we calculated, right? We calculated. The A part, whatever we got the answer, it is same we have to do. And the armature current at no load is 10% of rated value. So 10% of rated value we have to take. That means whatever rated value we found out, right? By using the power formula, we found out rated value. This 10% we have to take. Okay. So let us go for the no load speed. Very simple. B part I am going to solve. No load speed. In order to find out no load speed, I will take omega naught I will take. This is we have to find out. So simple. How we have to get the relation? We know EG formula. That is just now we did. kV into omega into Ia. This I am going to take EG naught for the no load. So omega naught. From this can I get omega naught answer? Yes, it is EG naught divided by kV into Ia. So why am I writing EG naught? I can directly write EG, right? Because EG, as we know that we have already found out EG. But one problem is there. What is that problem? They have said that you are going to take the EG value considering the fact that IA will be, armature current will be, at no load will be 10% of rated value. So whatever is the rated value here, 49.73, I am going to take the 10% of that. So IA becomes 10% of 49.73. That will be equal to 4.973 amperes. Simple, okay. 10% means 10 by 100. So 1010 cancel. So just point just shifts here. That's all. So IA we got. Now EG naught we have to find out. EG naught is equal to, what is the formula we have studied? EG naught in order to find out we have to go by VA formula. VA is equal to IARA plus EG. So EG naught becomes VA minus IARA. Do we have to find out VA again? No, no need to find out VA again because here VA we found out using VA. So VA we have to take the same value. It doesn't change. VA whatever we have got, we are going to take the same value. Only thing is that IA we are going to change. Remember they have said that they have to change only IA, rated current. VA whatever you got, you take same as it is. Even Okay, so EG naught becomes BA value same as it is 271.63 minus IA value just now we got 4.973 into RA value armature resistance given in the question is 0.25. So you'll be getting the EG naught value as 270.39 volts. This particular thing I have to substitute here. Whether IF will change, no, KV also same. So omega naught you will be getting. So omega naught, which is the no load speed, you will be getting it as Eg naught divided by KV into VF IF. So Eg naught is 270.39 divided by KV value is 1.2 into IF value is 1.146. So you'll be getting omega naught value as 196.62 radian per second. Always remember, if the answer you will be getting into us, it will be getting, you will be getting the answer as radian per second. If you want to convert into RPM, what you have to do, as I said, you have to just multiply with what, 30 by pi, not pi by 30, it is 30 by pi in order to get it in RPM. So you will be getting omega naught in RPM as 1877.58 RPM. This is no load speed we got. So second part of the question is done. No load speed we calculated. Now we have to go for the third part of this question, speed regulation. What is speed regulation? No load speed minus full load speed by full load speed. So it will be no load speed minus full load speed by full load speed. No load speed we just calculated. This is no load speed. 1877.58 minus what is full load speed? Full load speed is nothing but the rated speed what is given in the question. Right? It is the maximum speed, whatever is there. So 1800 RPM is the maximum speed. Divided by 1800, which will be getting it as 0.043. Just multiply by 100 in order to get it in percentage. It will be 4.3%. So this is the speed regulation you are getting. Okay. So I hope you understood. A part was quite lengthy one. Okay. So anyways, I have explained everything. You can just see the PDF also. I'll just upload it. Okay.